Everything you know, every star, every galaxy, every atom, will one day disappear. Not in a bang, not in a flash, but in silence, stretched across trillions of years, so vast that numbers alone can barely describe them. This is how it ends. Right now, our sun is only halfway through its life. It still has about 5 billion years left before it swells into a red giant and finally fades. But compared to the true lifespan of the universe, our sun's entire existence is barely a flicker. To understand how everything ends, we have to imagine timescales so vast that all of human history, every civilization, every war, every discovery, is less than a single second on this cosmic clock. Right now, we are living in what scientists call the stelliferous era, the age of stars. Trillions of galaxies fill the sky, each one glowing with billions of stars, forming planets and lighting up the darkness. This is the universe at its most alive. But this era will not last forever. In about 100 trillion years, the last new stars will be born. After that, star formation stops completely. The gas and dust needed to create new stars will run out, and no new light will ever be born again anywhere in the universe. One by one, existing stars will begin to die. Small red dwarfs, the most common and longest-lived stars, will be the last to fade, slowly cooling over trillions of years until even they go dark. Galaxies themselves will begin to change. Without new stars to replace the dying ones, galaxies will grow dimmer and dimmer. Eventually, entire galaxies will be filled with nothing but stellar remnants, collapsed cores of dead stars that no longer shine. What's left after the stars die? Three main things. White dwarfs, the cooling embers of smaller stars, will slowly lose their heat over unimaginable spans of time, eventually turning into cold, dark objects called black dwarfs. Neutron stars, the incredibly dense remains of larger stars, will sit silently in space. And black holes, the true giants of this era, will remain, growing slowly by consuming any matter that drifts too close. This period is known as the degenerate era, and it will last far longer than the age of stars ever did. For quintillions of years, black holes will dominate an increasingly empty and silent universe. Occasionally, two black holes might collide and merge, creating brief flashes of gravitational energy in an otherwise dark cosmos. But these events will become rarer and rarer as matter spreads further apart. Even black holes are not truly eternal. Through an extremely slow process called Hawking radiation, black holes very gradually lose mass over time, releasing faint radiation into space. This process is so slow that even the largest black holes will take an almost incomprehensible number of years to fully evaporate. Numbers so large that if you tried to write them out, you couldn't finish before the process itself completed. But given enough time, even the most massive black holes in the universe will shrink and eventually vanish completely, leaving nothing behind but empty space. At the same time, something else is happening on a much larger scale. The universe itself is expanding, and that expansion is accelerating. Galaxies that we can currently see in the night sky will eventually be pushed so far away that their light will never reach us again. Space itself will stretch faster than light can travel across it. Over time, even nearby galaxies that once appeared close will disappear beyond an invisible horizon, gone forever, as if they never existed. Eventually, the observable universe will contain almost nothing. No stars, no galaxies, no black holes, just an endless stretch of cold, empty space, with matter and energy so thinly spread out that nothing meaningful can happen anymore. This final state is known as heat death, or the Big Freeze. There will be no light, no heat, no motion, only a permanent, silent stillness that continues forever. But is this truly how it ends? Not every scientist agrees. Some theories suggest a completely different outcome. In one idea, called the Big Crunch, the expansion of the universe could eventually reverse, pulling everything back together into a single point, possibly triggering another Big Bang. In another idea, called the Big Rip, the expansion of space could accelerate so violently that it tears apart galaxies, stars, planets, and even atoms themselves. And some physicists believe there could be laws of physics we haven't discovered yet, ones that could completely change everything we currently predict about the universe's fate. The truth is, we are still very early in the story of the universe. Even trillions of years from now, the universe will still be considered young compared to the timescales these theories describe. What happens after the stars fade, after the black holes vanish, after the last light disappears, remains one of the greatest unanswered questions in all of science. What scientists discover next could completely change everything we think we know about how it all ends. If this made you think differently about time, the universe, and the vastness of everything around us, hit like, subscribe, and join us for the next journey into the unknown.